Hi there, and welcome to the 19th episode of the A-Star Interview podcast series. My guest today is Glyph Lefkowitz, who is the creator of the Twisted Networking Framework for Python, and an employee of Rackspace, whose office he is currently at, and who is generously providing him with the time to do this interview. I'm very excited to talk with Glyph because I personally spend most of my time doing Python programming, and only a few of my guests previously have been Python programmers, but Glyph is one of the best Python programmers out there. And so I'm very interested to hear kind of how he got there and how he thinks about the world. And that said, we're going to jump straight into it with our first question for Glyph, which is, Glyph, what are you working on right now, and why are you working on it?
So I guess I'm working on a bunch of different things. I work on Twisted, and I work on several other projects within Rackspace. The main one within Rackspace, I guess, that I could talk about as open source, is called Mimic, which is it's a fake version of the cloud. It is a bunch of back-end APIs implemented to do nothing but remember the nothing that they did. So, for example, if you want to provision a server in the cloud, basically regardless of which cloud it is, you're going to be waiting a little while for it to build, for the OS to boot, for various things to happen. With Mimic, you don't have to wait. You don't actually get a server, but you don't have to wait. What you do is you say, give me a server, and Mimic says, okay, sure, you got a server. And it can do that instantly, because all it's going to do is sort of react in the future, say, yes, you have one. But the interesting thing about Mimic is that you can also tell it, give me a server that's broken, and it will react as if you tried to issue, like you had issued a request against a real cloud, and that cloud had broken. And since those of us in the cloud industry want the cloud to work, we try to make that not happen, but nevertheless it does. So the reason that I'm working on that is that my colleague, Leica Javan, who came up with this project, was working on the QE sort of quality engineering process for the Rackspace Autoscale product, and she noticed that the tests took a really, really long time. And so the reason that I got interested in it was that she realized that they really needed to have a great set of tests that would simulate in an integration testing scenario all of the horrible things that can happen when you're using the cloud and react intelligently and accurately to all of them. And I'm a big believer in test-driven development, and one of the things that working on Twisted has taught me is that the scenarios that you most need to test are the ones that are not going to happen that often. So, the happy path, the thing that just works all the time, you're going to get tons and tons of testing out of that. You don't have to do test-driven development or anything special. Like, you just use your software and you see if there's bugs in the usually works case. And so Mimic really helps you test all of those things about your provisioning infrastructure that don't work. Like, what happens when I try to make a server and I don't get one? Because typically things that'll be talking to a cloud API need to make 10 or 20 servers, and sometimes they're making them in a very precise arrangement where you need 3 database servers and 5 web servers and 2 caching servers, and you need to make sure they all come up. And if some of them don't, you really need to make sure you retry, that things don't, that if the cloud APIs don't give you all the servers you need, or the hardware physically fails, right? Like, ultimately all these APIs represent actual real computers that occupy the physical universe, unfortunately. And in so doing, they can, like, no matter how great the cloud backend is, you'll still get those errors, you'll still get those failures. And so testing that you're by using those cloud APIs, that you get a nice consistent view of the world, that you will always retry, that you will always only introduce delays, basically, and not introduce big noticeable failures to your clients. Mimic can help you do that. So Mimic is sort of, in that sense, a continuation with many of the things we did with Twisted, allowing you to fake out and test things that can happen on real networks, but that you're not going to see when you're testing your app for real.
Huh. I guess I'm sort of a small-time cloud user, but I've never even heard of somebody talking about actually testing the cloud infrastructure provisioning.
Well, one of the things that happens when you get big is you end up. So you start off, you provision one server, and you're done, right? You like click on the control panel, and you're like, okay, I'm finished. And then later you're like, okay, now I need 3 servers, and you click on it in the control panel, and that's a little bit repetitive. But then later when you need like 1,000 servers, you really don't want to click that much, so you end up writing some provisioning infrastructure. And actually, one of the things that's really nice about Mimic is that it makes it a little bit makes it easy to start testing that kind of stuff before you get to that huge scale. Because if you want to write a test that creates 1,000 servers, right? You want to test the scalability of your deployment tool. If you do that against a real cloud, even if you delete those servers real fast, that's still going to bill you for a not inconsiderable amount of money. And if, as has happened to me, you start your script, you go grab some coffee with a friend, you go home, you forget that you ran your cloud provisioning test script, it has a bug, and you accidentally left all 10,000 servers up and running, you will get a bill for that, and somebody will notice. So it's definitely worth getting that kind of thing sorted out early. And the other thing that's nice to do early is if and Mimic does not totally support this because Mimic does not give you a real server yet. We do have plans to make it eventually provision, like when you tell it to give you a server, it will give you a sort of a virtual IP that it creates on your computer as an internal IP, and then like make a Docker container in the background. So a sort of virtual computer that will go away, but you could potentially run your, let's say, Chef provisioning scripts against, right? And once we have that, you'll be able to really test your whole setup. And even if you only have 2 servers or 1 server in the cloud for real, Mimic would then allow you to test your dev setup, right? You could test to say, well, if I bring another developer onto my team, I could just tell them to run this script, and I know the script works because I've tested it against Mimic, and it's like run some stuff. So we're not quite there yet. It's mostly for the higher scale folks at this point who need to test just the part that makes a whole lot of servers, but eventually we'd like to make it so that it gives you a realistic enough view of having made 1 or 2 servers that you can then run shell scripts on them and make sure that they sort of do roughly the right thing. It'll never be a complete cloud. It'll never boot whole VMs or anything like that, but we'll we want to make it the sort of thing that isn't just about making millions and millions of servers. It's also about if you make 3 servers, but they all really need to be there, you can test, especially because like at 1,000 servers, you'll see some of those not show up, right? Like there will be a failure rate that will be some number of percent. And even if it's point something percent, with 1,000 servers, you'll see a couple failures. The problem is if you have a deployment where you have a tool that creates websites for like ice cream shops, and you just need 2 servers, but one's the web and one's the database. If your script fails, when that happens to one customer, that's a big deal, right? Like if you have 1,000 servers and you don't get 2 of them, like they're all probably the same. At that scale, you're not. It's probably okay that you didn't get those 2, and you can sort it out later. If you have 2 servers and one of them is a database server and it doesn't show up, you really care. Like that's actually super important. So we want to make it scale down and kind of make it a more popular thing for people to test this kind of stuff, even if they're not scaling up so much.
Okay. And so what tools are you using to actually write the cloud provisioning testing process? Is that like a Chef thing, or do you have bash scripts that set things up and shut them down?
Well, so like I said, Mimic does not do that yet. That's like a future plan to bring up the sort of, not just to pretend to bring up a server, but to actually bring up a thing that's enough like a server that you can fake it. Mm-hmm. Our goal with that will be to make it so that it kind of doesn't matter. Because when you provision a server, one of the things you can do is you can give it a shell script to run at its first boot, and or a cloud config file, which is sort of like a shell script, but with a bit more integration with your platform, like installing packages in a declarative way instead of just having the command line to install them. That sort of stuff. We would want it so that you could just give Mimic a shell script, and then you could use any tool you wanted. And it could install Chef, and then Chef would talk to something. And there's obviously a huge amount of diversity in how people like to provision their servers. So if we did a testing thing just for one of those, it would be a sort of limited utility, especially since we're starting at, like, what we're really focused on now is just faking the cloud provider, so faking out Rackspace's API. And so that's where we're, like, the tooling that we're using now is all like the Nova OpenStack clients, that kind of thing.
Okay. And what about Twisted? You still in charge?
Nobody's really in charge of Twisted. It has its own agenda, and we merely acquiesce to its demands. In all seriousness, though, Twisted is, and this is sort of one of the things I'm proud of, Twisted has a very egalitarian process. So the process is really what's in charge, and the process is everybody who's a committer has the ability to review code and to land code, but only if it meets the requirements that are the requirements of quality and, like, documentation that we stipulate are the shared community standards for that sort of stuff. And we mostly document that policy, and when we don't document it, it's a bug. So I occasionally make executive decisions. I do retain that right. But I kind of view it as a failure every time I have to make a decision that really, like, is a direct thing that I'm doing. That means that the process has failed, and so that's. I mean, I do still do, like, technical leadership. Like, I just created a new package in the Twisted org on GitHub, but not part of Twisted itself, called Tubes, which is sort of a next generation flow control data processing API. And so when I do stuff like that, people still pay attention because I'm, like, the Twisted guy, and I'm setting the direction for the project. But I have to set that direction in, so some open source projects have a leader who sort of anoints themselves the dictator for life, and it's kind of jokey but kind of not. But I tried to acknowledge very early on in the Twisted project that while I might be the founder, and that's how I usually characterize myself, as the project founder and not the leader, while I might be the founder, there would be no project without, like, participation by active contributors. And so my ability to lead the project depends intimately upon what random college students who might find it fun to work on Twisted think. And so I try to lead from behind in that way, where I show people what I'm doing and why it's a good idea, and hope that I convince them.
Okay. And is that process, I guess, modeled off of processes you've seen in other projects, or is it just sort of what naturally made sense to you? How did you end up with that arrangement?
Well, so the interesting thing about the process is that if you look at it now, it's sort of a bog standard open source workflow. You just there's code review, and there's you have to file a ticket, and then once there's a ticket, somebody can make a branch, and then they ask that the branch be reviewed, and once it's reviewed, there's some comments, and then the author addresses the comments, and then it gets merged when it passes all the continuous integration infrastructure. We have a big build.bot farm and a whole bunch of different platforms. So it's more or less what a lot of projects do right now. The interesting thing about it for me was that we were a really, really early adopter of this process, to the point where it was so weird when we started doing this, like comprehensive 100% code review, 100% test coverage requirements. We also have a 100% docstring coverage requirement. You have to document everything. And if you're adding new features, you even have to write narrative documentation. We originally didn't have the doc requirements, but even just the test coverage and code review requirements, when we started doing that back in 2004 or so, I think, is when it started, it was so unusual. We had to have, like, a catchy name for it. We called it the Ultimate Quality Development System. There was a big wiki page about it. We had constant fights with contributors, where contributors would show up and say, what is this? How come I can't just mail you a patch that changes something at random like I do with every other project that I contribute to? And nowadays, with the rise of GitHub, everybody does code review all the time. Like, many projects still don't have quite the same rigor that Twisted does about, like, there's a formal process where something is in review and it's awaiting sort of pronouncement, and then it's been reviewed where it's out of that state, and, like, nobody, like, the author needs to respond to it before submitting it again. Like, most projects just kind of leave pull requests open forever and they just kind of linger and get comments on them or not. We try to avoid that because we had some bad experiences with people just leaving comments on things in sort of a drive-by way, and so we wanted to make sure that like if you comment on something, you're either explicitly saying, here are some ideas, don't mind me, or you're saying, I am reviewing this, I'm either giving it a pass or a fail. And so so it's a slight tweak on modern process, but it was like massively revolutionary when we first pioneered it.
So where did the revolutionary ideas come from?
It really came from the fact that after we had a big burst in the number of contributors, quality went way down, and we had a bunch of... luckily, we didn't have any terribly embarrassing releases, but we did have a long period where we couldn't really release anything because we were not sure about the quality. Things were broken. We had a whole bunch of new APIs that nobody had looked at, and like we had one contributor who was adding a whole bunch of stuff without really understanding the rest of the system. So, and at the time, I was at a startup where we had to deal with a lot because of the evolution of the marketplace. We just had to deal with a lot of changing requirements, and we were working on Twisted. So we instituted this process as a way of just saying, let's make sure that every change is an improvement. Like, let's just be sure that we're not backsliding in any way. And it really helped. Like, it really, I mean, to this day, Twisted has a very good reputation for quality. Like, there's a lot of, shall we say, myths around the project being complex and hard to use. I think that came from, there was a period a long time ago where we really didn't have much in the way of any documentation. We didn't have doc strings. We didn't have narrative docs. And that since has been really, like, massively improved. There's a, if you take the documentation and turn it into a book, it's like 400 pages. So there's plenty of docs. And so it's not as confusing as it used to be, but the reputation for quality has just stayed there all along. All of our users upgrade all the time. People very rarely have issues. So it came from that desire to be able to just tell users, hey, upgrade, it's not going to break. Like, we know it's not going to break. We have regression test coverage. We have announcements. Whenever anything gets removed, like, there's a specific change type in a specific place you look in the change log to make sure you're not still using that deprecated thing which got removed in this release. You've always got at least one release before things get removed. Like, if we're going to change direction, if we're going to deprecate something, you always have warning. And so that really, I mean, it worked for that. It really made it so that we've had a very good reputation for many years for being really solid, and not just solid in, like, you can deploy it and not worry about it, but solid in that you can pretty much just keep upgrading, and if you pay attention to the warnings, like, you'll be fine.
Okay. Let's ask some questions about you now. What are your main non-technical interests?
So there's a great tweet from David Reed, which I should link you to at, I guess if you have show notes, you can put it in there. But it's, what's your job programming? What do you do when you're not programming? Or sorry, what's your job programming? What do you, what's your hobby programming? What do you do when you're not programming? Think about programming. So I do I have a lot of technical interests. They're varied. I'm interested in video games and like video game design. I'm interested in computer art, but a lot of those interests eventually sort of converge on something computery. I guess my main interest outside of computers per se would be science fiction. I'm a huge science fiction fan, but of course I read all of the science fiction novels that I consume on a computer of some shape or size. So I spend a lot of time thinking about computers.
So segueing off your programming tweet, how old were you when you started programming, and what motivated you to start?
Well, so my career in programming started very, very slowly. So there's a version of this answer I could give where I could say I was 8. There's a version that I could say I was 12. There's a version I could say I was 17. It sort of depends on what you mean by programming. So my dad's a programmer, and when I was about 8 years old, I decided I wanted to make I wanted to be a writer. So I wanted to make a video game like Zork, because to me that was writing. I had computers my whole life, and there was just no real difference, no boundary between a book that you would read on paper and then an interactive video game that you would read on a computer screen. So I wanted to make a game, but I couldn't figure out how to make the game part. And I asked my dad if he had time. He was a pretty busy guy. He's a high-powered programmer doing interesting technology infrastructure. So he taught me a little bit of APL. And APL, if you don't know it, is not the first programming language one would normally teach a child. It is all a bunch of Greek symbols that are given special meaning. It's a mid-fix programming language. So like Lisp is a prefix programming language where you have every expression begins with sort of an open parenthesis and a function name, and then everything else goes after that. Everything in APL is like operators that go between two things. So, like 3 plus 4, right? That's a typical mid-fix operation, except all of the stuff is operators. So, like, to do some I/O, you would do, like, I don't even remember how this works, really, but you would do, like, something quad and then a file, and quad was, like, I/O operator, which meant write, sort of. And so anyways, he taught me a couple symbols, which I forgot all but one of. And so my first experience programming was I could assign go west, or I could assign west to a particular string. And so APL has an interactive interpreter, like Python. One of my favorite idioms that my dad has used is the phrase space over 6. APL's prompt was just 6 spaces, so it would just indent everything that you were typing in, and all the output would be on the left. So it would space over 6, and I would type west, left arrow, and then quote, and then a string. And then when I would type west, it would print that out. Mm. And then I did that over and over and over again to like build up my little like initial game world, because I had some idea of the map I wanted to have and where I wanted things to go. And I knew that I could get west to do this one thing. And then I got really confused because I couldn't figure out how to make west do a different thing the second time. I had no concept of what I was doing, no concept of data structures. And then there was this period where, so that was on an Amiga. I had the APL 68000 environment on my Amiga, and then I got a Mac later, and on the Mac they had HyperCard. And so on HyperCard, I could make a button that would go west, and then that would take you to a different card, and then I could have a button in the same place which would go west again, and that would be different. So still no notion of data structures, still no idea what I was doing with programming, but I could at least get that like some notion of state, right? I was onto the part of the Turing machine in my personal development where I could move the head now. I couldn't put any instructions on the tape, but I could at least advance the instruction counter. Finally, I started, so then after several years of building this large, increasingly elaborate HyperCard stack, which had scripts, because I like learned that you could sort of click on a button and then inspect it and then edit the script, which would open this full-screen dialog box. Like, it was literally a Mac modal dialog box where you would edit all of your programs. I eventually realized that you could make buttons do certain things by having a script that said on mouse up and then like some text. And I had a giant HyperCard reference manual. And initially it was all just like, what could I do? Like, there were just things that I could make the computer do, right? They were commands. I had no notion of flow control or logic. And because all the logic was encoded on which card you happened to be looking at the moment. It was just different. So there was no need for conditionals. Sort of like object-oriented programming, where you would just have a different object that had different behavior, except the objects were things I had physically dragged onto this canvas, very carefully positioning them so that the pixels were all in exactly the right spot, so that when you clicked on the Go West button, the whole user interface was copied onto every single card so that you could see it looked like a program. or looked like an app that was actually had some internal logic. And after years of this, I finally sort of read about the if statement, figured that out, and then after about a year of that, I finally found out about variables, and it completely blew my mind. So by this point, I'm probably 14, maybe a little younger than that, maybe 12, but like I have this distinct memory of going upstairs to tell my dad, like, have you heard of these things? Variables. This is amazing. Like, how did I get anything done? And he looked at me like I had grown a second head, because at this point, I'm sure from his perspective, I had been programming for like 3 years. And so he must have had no idea what I meant. And so at that point, for then a couple of years after that, I was like, wow, he must waste all kinds of time at work just copying all those buttons around to all the different cards and the programs he's writing, because he hasn't figured out variables yet. And then later I was like, oh, no, he knew what a variable was. That was so my ascent to like sort of sensible, what people would consider programming, was this very arduous journey where I really had no idea what I was doing until many, many years into it. And then after I sort of hit that epiphany, I did a couple more months worth in HyperCard, and then I realized that I just wasn't really programming. I figured out that like there had to be a lot more to it than that, and I started learning C++, and that was my first real programming language. And I like went to computer ed high-tech camp, which was a computer camp for kids, and I learned how to code in C++, and I learned how to code in Lisp and Java and a bunch of other programming languages. And at that point, so by the time I was like 13, 14, yeah, actually that story I told must have been 12, because 13, 14 I had already been there and been going for a couple of years, and kind of. So then at that point, you know, all the margins of my notebooks in high school were all just full of programs, because I was bored doing everything else in school, and that was the process for me. Was I eventually like actually learned to program, and then once I knew about data structures, object-oriented programming, functional programming, immutability, all that lovely stuff, once I got to that point, I loved it as an activity. I also think this story, and I know a lot of your audience are sort of like up-and-coming, more junior programmers who are trying to figure out how to get better at their craft. So one heartening thing about this is like, I'm really bad at it, and I was just really lucky to have like this enormous runway. And I know that was like a tremendous privilege to have all that time as a kid, but you can get good at it over time, no matter how terrible at it you are when you start, just because I'm like living proof.
So what was it that motivated you to spend all those years dragging things around on a HyperCard?
I really enjoyed, like, I mean, computers, and this is true even now, I guess, but computers were always sort of the future to me. They were this idea of, they were just so much more entertaining than everything else, right? Even a terrible video game was more fun than a really good TV show, because you were invested in it. You were focused on, you know, you were kind of in it. You were interacting with this machine, and it was, and I only sort of found this out later, but I have terrible attention deficit disorder, and one of the things about computers was they just held my attention, and nothing else could. And at the time, I just sort of assumed everybody else felt that way also, because that was just how brains worked. Like, you just couldn't pay attention to anything. Now I realize there's probably some neurotypical people out there who could sit down and take a math test and actually finish the whole thing. But at the time, I just assumed that nobody could, and that computers were this wonderful way to like express things in a way that people could actually pay attention to. So, and I mean, I still think that that's true in the sense that like interactivity is a really powerful medium, and you know, computers are tools for delighting people, right? As frustrating and as difficult as like technology can be, you could do basically everything you could do on the computer with something else, right? Like maybe we couldn't do video, but we could be having this call on like a completely dumb circuit switched phone, right? We could be, you could do your taxes with a pencil and paper. You could, you know, everything You can schedule meetings on paper calendars. You can do everything that you can do with a computer that's sort of a productivity task in a more boring, tedious way. Without the aid of technology. So, I mean, it was really about games for a long time for me, but I always had sort of an eye on more serious applications as related to the games, even in those very early days. I just wanted to learn how to make stuff on computers because I felt like that's where everything was more fun if you did it with a computer.
Is that how you still feel today?
I try to feel that way. I try to hang on to that. I do feel that way sort of in the deepest core of my being, but then I run a setup.py that tries to sudo and run a shell script and download some stuff and write some files as root into my home directory, and I get mad. I get mad at computers. They definitely don't work like they should. I feel like we could, especially I feel like as a member of this industry, we could do better, and we could really be holding ourselves to a higher standard. But that is the standard I like to try to hold myself to. Is this a delight? And I know I fall short. We all fall short on a regular basis. But that's what we should aspire to, even for maybe even especially for dev tools, because it all starts there, right? Like developers kind of put something of themselves into what they're developing. If you're not having a good time while you're developing it, that's going to come through a little bit. And the more you're having a good time while you're developing it, the more energy and effort you'll be able to put into those details that will make your users enjoy what you're making. So, so I still believe that, and I want to believe it more.
Okay. I've definitely had some less than delightful moments with setup tools.
I love how that's like if you talk to a Python programmer and you have this conversation about delight and wonder and like computers being good things, they're like, yeah, but setup tools. That's always the example that comes up. My great hope for that actually is Donald Stuffed, who is another racker. He also works at Rackspace. He has been just doing fantastic work, and even before he came to Rackspace. This is one of the reasons I think he was brought on, is he has just been doing such fantastic work, making pip work, making PyPI work, making all of the pieces of that experience actually kind of hang together better. And it's a hard problem, right? Like we should give those guys some credit for all of the work that they're doing, being challenging to work in so many different environments and so many different scenarios, and they also have to deal with this tremendous legacy of everyone screwed their system up to work with some older version of setup tools, and now they've fixed the problems, but they can't break the systems that are already working in some completely ridiculous way. So I have a lot of respect for them. I think that they've brought it forward a huge amount in the last couple of years, and really the last sort of piece of that puzzle is all about getting the user experience parts to line up and work better. And the recent, I believe it was pip 6 release, really improved that a huge amount, because one of my favorite bugaboos about pet peeves about the way that pip worked was it had mechanisms for caching files. It had mechanisms for speeding up the install experience, and they were all off by default. And you had to know that they were there and know what they were called and turn them on and give them a place to put stuff. And now pip automatically detects what platform you're on, what the right place to put cache files is. It has an HTTP cache, and it will automatically use it. And so they're making steps in that direction of having it just do the best thing that it knows how to do by default all the time. And the wheels infrastructure has also helped that, where you do pre-built wheels of your Python package for macOS, for Windows, and upload them. Linux has the problem is so complex on the Linux platform because there's so many different things that Linux can mean that they're still sort of working out how to get that to work, but they want to. And for a long time, Setup Tools was just stuck in this sort of rut of, oh, well, if you did things correctly all the time, then it would just work, and it's too bad that everybody hasn't, set up their systems in exactly the way that we expect them to be. And now they're much more like living in the real world, trying to get it to be a good experience for users no matter what's going on their computer. And they're succeeding. Like, it is getting better.
All right. Well, that seems like a good place to ask the next question, which is, what is the most painful technical or career lesson you've had to learn, and how did you learn it?
So we talked about this a little bit already with that, the way that we came to that twisted process that we mentioned. That twisted process originally came from a period where our requirements were changing so quickly. We didn't exactly know what application we were building. And this was not Twisted itself. This was actually in the company was called DivMod, and the product we were building was called Quotient. It's a sort of Gmail before Gmail type of product. And the product that the changes that we had to keep trying to make all resulted in this sort of gradual increase in complexity, decrease in maintainability, and general sort of decrease in the pleasantness of working on the system, which meant we moved slower and slower as time went on. And so really the most painful lesson there was if you don't have a process in place, if you don't think about the people factors involved in how your software is going to evolve over time, you will end up with an unmaintainable mess that you'll be stuck at a local maxima where rewriting the whole thing is like untenably expensive, but changing it in any way is also untenably expensive. And so that is a sort of software project death that many projects eventually find themselves in, especially like commercial projects where the requirements can change and things do move quickly. Open source, you could sort of always stop and recover from that just by allowing your project to sort of appear to die from the outside and then fixing it up as long as you can maintain some interest in it and then eventually getting things back on track. So the lesson was you have to have process. Basically that they all lied to us. They told us, go learn to use computers. You won't ever have to deal with people. It'll just all be about machines. And like, nope, you have to deal with people. You have to deal with like apparently illogical decisions, and you have to communicate really well. Another thing, which this is a lesson I'm still learning on Twisted all the time, where I will have an architectural vision for how something should be developed. Like I'll make a small change, and I'll think that is an example that has like a temporary workaround part and like a long-term vision part, and the long-term vision part seems obvious to me, but that long-term vision doesn't get carried forward by other people. Instead, they sort of think that the hacky workaround thing is actually the way that you should be doing things. They'll copy that part, and eventually the sort of vision for the whole thing will degrade, and then nobody can really understand how it's supposed to work, because a couple people worked on it who thought it was supposed to work in sort of a good way. A bunch of other people worked on it who didn't realize which way it was supposed to work and just kind of made stuff work. So you get this system which is got a split brain that doesn't quite know how it's supposed to fit together, which means it doesn't fit together, which means that understanding it's really hard. So and that's a lesson I think that a lot of people, like a lot of senior engineers, learn over and over again in increasingly subtle ways throughout their career. Like, no, you really have to write stuff down, and you have to write stuff down in a place where people are going to see it. And you have to make sure there's a process for them seeing it. You have to make sure there's a process for like maintaining quality standards, testing, all that kind of stuff. And that has to be built into your project pretty early on. Like you can retrofit it, but it's a painful process to do so.
Do you have any thoughts on how to learn that process without just going through doing it the wrong way?
So the good news is that GitHub is teaching a lot of people that process in a sort of ad hoc way. Like, everybody does code review now all the time, which means that the main part of that process, where you have no knowledge transfer on your team, where one person sort of kind of knows how everything works and everybody else is afraid to make any big changes because they don't know if that person is like okayed it or not. They're not really sure what's going on. Code reviews are percolating that out. So people, I think, are learning the initial steps of that lesson in a much less painful way these days. I would recommend for people to study what has gone before in terms of process, read Extreme Programming Explained, Embrace Change. Don't read anything about Scrum. That's all like mostly for management folks and not really doesn't really go in a useful direction for technical people. But the origins of the Agile movement are a great place to learn some of those lessons. And another place to learn some of those lessons is actually read the docs.org. Like, read the docs in general, and also Django and specifically have a documentation process you can learn a lot from. And if you read about how they've given various interviews and things, you kind of have to Google around. There's no one central resource for this, but if you find things that the Django team has said about the way they do documentation, the way they perceive documentation, that's like learning from that example and seeing how they communicate how things are supposed to work in the Django project is really good. And finally, just learning about how to learn that you're wrong is actually a very important lesson to really focus on early. Learn stuff about cognitive biases and how if you do a thing and it doesn't seem to be working, one way to learn this lesson much faster with much less suffering is to notice that you're doing, like, that there is something about your development process that's wrong and fix it. So just the very fact that you come into a project knowing, like, okay, I need to think about process. Process is going to be an important thing. And carefully optimizing that trade-off between, like, you don't want to have a ton of process. You don't want to overburden people. You want to keep it absolutely as minimal as you can, but still figure out which parts are critical. The fact that if you're thinking about that from day one and you have no resources, you really don't know what the process should be, as long as you recognize things as, like, problems caused by process or lack thereof, and you think about, like, okay, how could I set this up in the future so that it wouldn't happen again, that lesson becomes a lot easier. You still have to mess it up. Fundamentally, you still will have to do it wrong, but one of the things that was so painful for me about learning that initially was I had no guidance that process was the issue. I thought that if I just fixed the technology, if I just wrote the right code, that it would be fine. And I mean, maybe that's true, but that would only be true in the circumstance where you can write so much code so much faster than everyone else that you can set all the examples, and the code is all so totally lucid and clear that everyone can immediately see what you're trying to get done. Which means that you need to be working, if you're on a team of 10 people, you need to work as 100 times faster than the next nearest person, because 10x isn't good enough, because you need to be writing so much code that they're going to look around the code base and see only your good examples. And finally, the reason you want to learn about cognitive bias is because if you think you can do that, if you think that your examples are so good and so obvious, and people just aren't understanding them, there's a cognitive bias called fundamental attribution error, where maybe you're not actually that good at communicating if nobody understands you. Maybe it's you that's the problem. So in order to scale your own efforts, like, you don't have to become a manager, but you do have to understand how the people issues around you are impacting your work. And if you look at it through that lens, you will have to do a lot less people management. You will have to, because you can set up a couple of lightweight rules, decide what's really important to you in your project. And it's different to different projects. Like, Twisted is all about test-driven development. I think that's a good one that's pretty universal. But you might have a project where the absolute most important thing is it's like a JavaScript project for beginners, and the important thing is it always has to work completely out of the box. Like, it has to be only one step, and nothing can ever require any kind of dev setup beyond opening it up in the browser. Like, that might be more important to your project than comprehensive test coverage, because it'll, like, break in an obvious way if people just run it, but that requirement has to be held fast. So just think about what it's a sort of processing what the values of your project are, and so that I want to be clear that there is hope. You're not going to spend all of your time just dealing with people issues. You still can spend most of your time on the technology, but if you want to be able to do that, you need to think about these issues up front and kind of get them out of the way. Okay.
So on the technology, what is your favorite programming language, and what is your favorite tool, and why?
That is a tough question. So I think my favorite programming language is Python. Python is kind of the best happy medium. Um, my favorite programming language in terms of like this is the way programming should work would be Smalltalk. I think Smalltalk is actually a lot better designed as a language. There's a lot fewer moving pieces. Conceptually, it hangs together a lot better. You don't end up with things like underscore, underscore, weakref, underscore, underscore, which you have to know about sometimes in Python. But the problem with Smalltalk is that it was like alien technology. It was from this strange future that never happened. So there were no tools. You can't really use version control with it. It has its own way of doing everything, which means it lags behind in almost every respect. Like there's not much you can do with a real practical Smalltalk. You could do some in very specific domains, like if you're making a kiosk in a mall or something, you can use Squeak, and like it'll be just this wonderful experience. You'll do all this really cool stuff. But Python really kind of compromises with reality. It doesn't have as good of a core object model as Smalltalk. It doesn't have as good a computation model as something like Lisp or Haskell. But it does have like a command line that just is an interactive interpreter when you run it. And it has like a simple C implementation that people were able to hack on for a long time. And it has and it has garbage collection semantics you can sort of understand, and it has these things that force you to write data structures like classes, as opposed to just like one of the big problems with Lisp is you just sort of wing it all the time with random conses of vectors of maps of hashes, and you like nobody knows what any of that crap is supposed to be. And like whereas with Python, you're encouraged to write things in this way that values readability, and the community has valued readability, and there is a great community around Python. So some of that stuff exists in like Java land. Java has a big, vibrant community, a lot of open source stuff that's going on, a lot of outreach efforts. They also care about diversity in the community, and so. But in Java, the programming language is just too painful. So there's this sort of continuum of like all these different choices, and Python still ends up in the sweet spot for me of the intersection of all of those things. And then what is my favorite tool? I guess it would have to, so I mean I have a bunch of examples that I could maybe say of what are cool tools and why, but I guess pip would actually have to be my favorite tool, because pip lets you do the one thing that is like the most important in programming, which is split up responsibility into different modules. And beyond even, I mean, that's one of the reasons Python's so great, is that its module system is incredibly straightforward and always available, right? Everything's a module. No matter, like, unless you're writing a tiny script with no .py extension, everything that you do is a module and can be imported. And pip makes it so that everything can be a package that's actually not just a module, but a module that's so isolated that it can work independently of the other thing you're working on, and kind of force you to stay honest and to keep it working and self-contained. So I think that would probably have to be my favorite tool. I mean, I also really like tools like, I like Twisted's test runner, Trial, which is just a great tool for like, it also meets that sort of compromise sweet spot of like allowing you to do integration testing and unit testing in much the same way, allowing you to get started. It does test discovery really quickly. It has a nice user experience on the console. It prints out little colors. Every test success is in green, every test failure is in red. And I certainly like I like Tmux. Tmux is a great tool for managing a whole bunch of terminal sessions. So there's a whole bunch of tools that do a whole bunch of stuff, but package managers, for all that we loathe them and they have all these problems, they're what enable us to build software that has like correctly factored responsibilities instead of having to copy everybody else's source tree into our repository and like create all that duplication. So that I'm surprising myself by giving you that answer, but
what are the other contender cool tools you were thinking of?
Another cool tool is Sphinx. Also another place which, like, Sphinx has a lot of problems. I don't like writing in restructured text, but I love the kind of documentation that Sphinx produces and that Read the Docs publishes on their website. I think docs are really an important aspect of any project, and read the docs makes it easy to integrate into your workflow. Travis and coveralls, I both love like the idea that every time you do anything to a pull request on GitHub, you just get this instant feedback. I like BuildBot is a great tool. Twisted uses BuildBot for testing in a huge variety of environments that Travis won't let you. Like we support Windows. We support Windows XP. And we intend to continue doing that until people actually stop using Windows XP. We want to be able to get our software on whatever computers are out there and running. So yeah, like there's a whole bunch of them. I mean, I guess this is less a favorite of mine since I went to ebooks for everything, but LaTeX is also another great tool. Also on the documentation front. So yeah, I'm just trying to think of other things that I run on a regular basis. I would be remiss if I didn't mention Docker. Docker is a pretty cool tool because it lets you, similar to the way pip lets you separate your projects into like modular code bases, Docker lets you separate your concerns. Like it allows you to build these containers that like completely encapsulate everything your program needs. So like you get this nice view of what it is your application needs around it. So even if you don't use Docker to run your thing all the time, the fact that you have a Docker file that works means that you actually know what you depend on, as opposed to like a lot of things they've got their requirements.txt or whatever, but then there's the README that's got a whole bunch of special instructions for things you have to do before it'll work. And Docker is starting to push towards more of a culture of, nope, just works, just run it. It just works no matter what. And I think that that's a better place to be. That gets us closer to that delightful experience of using a computer when you follow the instructions and they actually work. And, you know, just because you forgot to put a pydistutils.cfg into your home directory, nothing works. So because Docker lets you say, nope, I put everything where it was supposed to be first. So I could keep going, but I think those are probably the highlights for now.
How should we measure how good a technologist is, and what are the key virtues of a technologist or a solution?
So this is a great question, and I wanted you to ask me so that I could subvert the entire premise of the question.
Right.
I think that there is this sort of toxic myth in the tech industry, largely, but it's particularly bad in software, because of these persistent myths of like the 10x engineer and that kind of thing. Which, by the way, if you look at the research on that, there was like one study that Fred Brooks cited that was like about this one group of grad students in like the 70s that did this one program thing. And there's a high degree of variability of skill in that group. Therefore, the entire industry now expects to find 2 orders of magnitude difference in productivity among people, which is interesting because the study only indicated 1 order of magnitude difference. So subsequent studies have shown that effect is much weaker than was previously thought, and also varies a lot depending on how you measure people. I think that we should stop trying to measure goodness. I think that the idea of merit is what leads to a lot of bad behavior in the tech industry. Like recently, Linus Torvalds said some really unfortunate things and then sort of didn't really apologize for them. And I don't mean to call out Linus or pick on him. He probably deserves to be picked on a little bit, but the point is not so much about him as it is about we have these heroes like Linus, like Richard Stallman, like, frankly, Steve Jobs, like, Larry Ellison, who are either, like Bill Gates, who are presumed to have some special talent or skill or some magical technical ability, especially in the open source community where our heroes are not billionaires. They're people who actually make the technology. And we believe that because they are really good, that we can allow them to get away with this. I think that the only effective metrics that people have come up with to measure are teams. And the way that you measure teams is you don't look at the software, you look at the outcome. You say, how many features did you ship? How many bugs did you fix? How fast can you do that? And measuring that from an individual, because very, very few projects are the product of an individual, even those that we strongly associate with an individual, like Linux is associated with Linus, or Emacs is associated with Stallman, those projects are, in reality, the contributions of thousands of people who do tons and tons of work. And all of that work is part of the product, and all of the how quickly are defects fixed and so on are that measurements of that aggregate group. So when you are evaluating someone, for whatever reason you're doing that, and maybe just judge people less is a good life lesson, but if you need to do that for some reason, the best way to look at it is not like how awesome, smart, great is this technical contributor, but rather how are they going to fit into this team? Like, do they have a skill that is going to be useful? And that skill sometimes can be what we might call non-technical. Like, for example, one really super effective contribution that can be made to some teams, especially those with a lot of people that we would traditionally think of as very smart, people who can write a lot of lines of code in a day, people who have very, like to use words like bijective mapping and total isomorphism or whatever, right? People who seem like super smart programmer types. One thing you can do if you have a team like that, you can bring on one person who's just really good at asking for explanations, who isn't quite following all this fancy crud that they're doing, is just trying to get it straight. You traditionally think of that sort of person as a low performer, as not that great of a programmer, but it turns out if you take a team of really smart people, you give them that other person who doesn't quite follow what they're doing, you force them to slow down and say, okay, here's what we're actually trying to accomplish. It'll turn out that maybe some of those bijective mappings and total isomorphisms are unnecessary crenellations that they're making the product harder to maintain. And so that person will then, by virtue of being able to ask a good question, synthesize the answer and document it well, has now improved the productivity of your team a huge amount. Whereas if you were to measure them in a tech interview in the sort of standard way where you say, write a linked list, let's measure the performance of, various operations on it. That so I think thinking of how people work together in teams, looking at aggregate statistics and figuring out how to respect what people are good at rather than try to sort of narrow down and hyper-focus on these one or two skills that we imagine sort of project out into being good at producing large software systems, but are actually only good for tuning small algorithms or whatever. And also, one thing that you'll find, I definitely saw this in the game industry a lot when I worked there, is you'll have people who are in the sort of traditional crazy smart category. You will get people who are very, very good at implementation techniques. So you'll have people who can write a very fast graphics engine, for example, who can squeeze the most performance out of something. And then you'll also get people who are also very smart and have a good theoretical background and computer science degree and all that stuff, but who are not good at the implementation side of things and yet bring a really important insight to how the whole system fits together and can say, well, okay, we have this really fast triangle memory allocation, triangle drawing algorithm over here, and then we've got this model data from the artists over there, and we need to hook them together kind of like this and not like this, because if we hook them together in this way, we'll get all these other benefits. We'll get this. We don't need to implement a super efficient algorithm for doing this thing because instead it'll just be done automatically, and we can skip all this work. So having people who have different skill sets is incredibly important for your success. And so when you're looking at someone and saying, are they a good programmer, you always have to ask that question in the context of a team. So that said, the one defining attribute that I can say that makes someone really good at programming is a desire for consistent self-improvement. Someone who wants to learn things and to improve the techniques that they use and discuss them. That doesn't mean someone who spends every spare minute, with their hobby being a programmer. Doesn't mean somebody who neglects their family life and is a Silicon Valley stereotype. but it does mean someone who will look at everything that they do and wonder, like, how could this be a little bit better? Because regardless of what that person's specialization, skill set, whatever they bring to the team, that is what you really want. So like that is what is going to enable them to grow and to improve over time. And so those are the folks that you want on your team. So my main conclusion from this perspective that I have is that the industry standard definitions of what makes a really good programmer are often backwards, because you'll get people who sound really smart, who build really complicated stuff, and who have a very high opinion of themselves and therefore don't believe that they need to improve. One of the best things about instituting that egalitarian process that I talked about on the Twisted project is I am not allowed to land code on trunk. If I want to, I have to get a code review just like anybody else. I have to get 100% test coverage just like anybody else. There's nothing special about me. And the fact that I'm constantly reminded of that is good, because people like yourself will come and ask me for an interview because I'm so smart and good, or whatever it is that the subject of the interview is. And so that tends to go to one's head a little bit. And the fact that I have to participate in this process where, when the sort of benevolent dictator for life types participate in their processes, when Linus participates in the Linux process, he can just say stuff and people have to listen, which is, I think, terrible and corrosive, mostly for him. Like, it's bad to have people listen to your ideas because you're in a position of authority. So if other people are looking at you and telling you you're a good programmer all the time, maybe it's time to step back and try to figure out a way that you can get some people to tell you that your code's terrible every so often, because that's the only way that you're going to improve.
How often do you get told your code is terrible when you're checking?
Every day. Every day. I try to, and if that ever slacks off, I know something's wrong. And in fact, I shouldn't even say every day. Every day that I get to write code. Like, if I have written some code, someone will tell me that there's something wrong with it. And I feel like I am actually, I don't want to project false modesty. I am a pretty good programmer. I do know what I'm doing. But the way that I got there was that process of constant improvement. And I'm 34. I've got a way to go before I'm at the end of my career. My dad has been doing this a lot longer than I have, and he still learns stuff all the time. I mean, he's learning Haskell and writing production systems in it. And nobody told him he had to do that, but it's just part of being a good developer, is constantly updating your skills and not just getting the latest resume buzzword, but figuring out what it is that you're supposed to learn from that technology.
Okay. How structured is your problem-solving approach? How much of your problem-solving comes from intuition or flashes of insight versus conscious thought? And I guess especially in your case, how much does test-driven development infuse your process on a day-to-day basis?
So this is actually an answer that changed for me quite recently. Maybe a year or two ago. But when we instituted that process for Twisted, before that point, I should say, I was all about just random flashes of intuition. As I said, I have terrible attention deficit disorder. That means that I have trouble paying attention to things except when they become hyper interesting to me. There's a phenomenon which is like a documented symptom of ADHD, which is it's called hyperfocus. You zero in on a task, and as long as you stay working on it, you stay incredibly focused on that one task. And then once you lose that, then suddenly you can't focus on anything for a while. And this is still true for me even today, those flashes of hyperfocus are where I get most of my work done. So that 10x programmer myth that we talked about, I really am the 10x programmer in that short window of time. And I will have these brilliant flashes where I write months of code in one sitting over 48 hours, and then nothing for a week. And in fact, much to my chagrin, sometimes literally nothing. I will sit down and I'll try to write something and it just won't work out for many days at a time. So I still struggle with that on a regular basis. when we went to the testing required thing on Twisted, I sort of overcorrected, and I went to a process where everything was all TDD all the time for many years, and I was super successful with that. So if you're in that first position, I would definitely recommend overcorrecting, overdo the TDD, learn how to do everything test-driven. Don't let yourself write a single line of code without it. That said, I recently saw a great talk by John Cleese, which is he talks about creativity. John Cleese, the Monty Python guy, and he talks about how there are two modes. There's the open mode and the closed mode. In the open mode, and he's not talking about programming, obviously. He's talking mostly about script writing, but it's the same story. If you want to be creative, you need to be in this state of mind where you're not afraid of failure. You aren't trying to you're not being particularly goal-oriented. Like, you might have a goal, but you will be interested in sort of playing with different outcomes that may not satisfy your goal exactly. And you have to be able to get into that mode and stay there for a while, and so that new ideas can come to you. But and as he mentions in the talk, you can't actually get anything done in the open mode. So it's necessary for creativity. But if you want to actually execute on your creative vision, then you need to go into the closed mode. And the closed mode is very goal-oriented, very process-oriented, very structured. And I believe that I don't know if he gives an exact guideline, but half and half, I think, is a good split between those. So what that means for me is that I write about 75% of my code completely test-driven, because all the code that I would write in the closed mode, it's very goal-oriented. I write a test, I write a fix. I write a test, I write a fix. And that's often quite good for getting started on creative stuff as well. You got a big open-ended problem, you don't really know where to start. It's very easy to get into a paralysis where you just stare at your screen and you think, geez, I could do this any 100 ways. So test-driven development can help there too, where just write a little test that's like testing one thing. Just write like one piece of code and start building out from there to kind of get yourself going. So I find that sometimes, though, I will hit these problems where I know what I want the implementation to look like, and I can't quite express it as TDD. And I'm religious about TDD. I think TDD is a fantastic tool, and it's one that, regardless of what domain you should work in, you should be using it, at least to some extent. And you should certainly have tests for absolutely everything. There's really no reason not to. But still, it's not always the right design tool. So sometimes I have to say, okay, I'm just going to write the implementation. I'm just going to think about how I want the computer to solve this problem. I'm going to write out the whole algorithm, and I'm going to see where it takes me. The important part of that process is that code, because it was not developed TDD, is great inspiration, but it's also garbage and needs to be thrown away. And so part of the oscillating between the open mode and the closed mode is I do a spike, like I will get a complete working implementation of some idea. And then I don't want to throw that all away because I've just spent 10 hours typing it out. And there's a bunch of stuff in there which I probably would want to use. But what I do is I will take that whole file and I will move it out of my source tree. I'll not commit any of it. Or at least if I do commit it, it's just like it's to a scratch branch. And then I will redo the whole thing one test at a time. I will look at each line of code that I've written and say, why did I do that? What was the point of putting that variable there? What was the point of adding this line of code? What was the point? And quite often what will happen is in that process, about a third of the lines will just disappear. Like I'll say, there's actually no reason for that. It's just junk. That was an approach I tried and it didn't work. And if I had been writing that code and committing it and actually putting it live, I would have a whole ton of dead code that I didn't understand because I had been doing a sort of creative sketch. So much as an artist, an oil painter, will do sketches and then just throw them away because they're not actually adequate to be a template for the oil painting, I will do sketches and throw them away, and then but because the programming is not exactly like painting, there are some valuable resources in there, I will make sure that there is a test for every line of code, for every interesting attribute, for every conditional branch that code has in it. But I will use the existing code as kind of a shortcut to make the tests pass. So I still do like red-green development, where I will start a test, make it fail, actually run it and watch it fail. And then the difference is I will sometimes just copy a piece of the implementation and then paste it into place. One thing I've started doing more of lately also is, instead of just deleting all of the code, I will delete only the logic. So I'll leave all of the method definitions and class definitions in place, and that way I get to a failing test rather than an erroring test faster, because I won't just get an import error that tells me that class isn't available. I'll call the method, nothing will happen. And one of the nice things about that also is, if you're doing proper red-green TDD, you run your tests with the stub, no implementation version, and it passes. And now you know your test is wrong, because it's definitely wrong, because all you've got there is a null implementation. So, is there more? Is that what you were looking for in terms of what how that design process works? Is there any other parts of that you're curious about?
I have a specific question about TDD, but also that's a good answer overall to the question. But if there's any other sort of how you solve more abstract problems, if you have a method for that, I'm also curious about that.
I think I don't really have a straightforward process that I apply when I have a problem. I think the closest that I come to that is I try to notice where my head is at, what I am doing when I'm solving a problem, and if I get stuck, I switch strategies. One of the sort of anti-patterns I had a lot earlier in my career was I would do a lot of bashing my head against problems. I would just try the same approach or small variants of the same approach over and over and over again, and now I will much more fluidly switch. I'll say, okay, I've been trying this for 15 minutes, it's not working. If I've been doing something for 15 minutes and it's not working, it's not going to work. So if it's a debugging problem, I will switch from testing to running under a debugger. Or if I've been running under a debugger, I'll switch to print statements. If print statements aren't working, I'll switch to strace or ltrace. If it's a design problem, I will, if I'm trying to write tests and I can't think of any, I'll write a sketch. If I'm writing a sketch and it's not really working, I'll back off to write tests. If I'm writing tiny unit tests and it's taking a long time, I might switch to a sort of bigger integration test and try to test from the outside in instead of the inside out. So I guess as a general process goes, it's just about having a lot of tools in my tool belt and switching between them to try to attack problems and see which one works for a particular problem. Ultimately, TDD is how I do implementation. TDD can really be helpful. And often, once I've got a sketch, TDD will inform the design at a lower level. I will think, oh, I really need to pass more parameters here. I don't want to have any global variables, right? TDD will help me refine designs, but the design process itself is really just as all over the place as I can make it, and only cleaning up things once I kind of know what I'm doing.
Okay. My specific question about TDD is a struggle that I've had when I've tried it, which is just figuring out which things to test. I haven't been able to come up with a good heuristic in my own head about kind of how comprehensive the test should be, what range of inputs they should test. Do you just test every possible input to a system and every possible logic branch, or do you have some kind of heuristic for how?
I guess there's just a life philosophy around this so I'm glad you asked that question, because that is something that a lot of people struggle with. And particularly, I think people struggle with it because they're not quite sure what they're trying to get out of TDD. The thing you should be trying to get out of TDD, the sort of goal of it, is actually fairly narrow, which is that when you are writing tests, when you're doing a test-driven project, you write some code, and then you want to make sure that it keeps working as you change it, and that you understand it, and that you have this documentation repository of the tests that kind of enumerate its properties that you were interested in. This can, as a secondary effect, this makes your software more reliable. It makes your software more robust. It makes your software deal with more edge cases. However, those are secondary effects. And if you start by saying, I'm going to make the most reliable system ever, I'm going to do everything TDD, I'm going to test every possible input, now you're not using TDD as a tool to solve your problem, which is presumably that you want your software system to do something. Now you're using TDD as a bludgeon to destroy all possible defects from the beginning, which means that you have now committed to a process that, whether you're using TDD or not, is like 10 times more expensive than the process you originally wanted, which was like write a program to do a specific thing. So the way that I decide what to write tests for is, if it's worth writing, it's worth testing. More specifically, what I mean is, you're staring at a file and you know what you want to write. You know that you want to write like if foo bar, right? You know that that's the correct solution to the problem. When you're writing the tests for that, what you have to do is say, why am I doing that? Like, what is the system supposed to do? What is the property that I care about that conditional should satisfy? And it's kind of like playing whack-a-mole, except you're actually playing the moles as well as the mallet. The goal is to make it so that when you write a test and it fails and it demonstrates some interesting property. It doesn't demonstrate absolutely everything about that property. It doesn't demonstrate every case that the software might ever be used. But it shows enough of why you would bother to put that if statement in, that you test the case where foo is true and test the case where foo is false. Because if you've got a conditional, that means that you only want it to run certain cases. And so what I would do in that case is I would write the test for it being true, and then I would just, in the implementation, just put bar. Like, just call bar unconditionally. Test passes. Foo's true, bar's getting called, great. Except I know now I actually wanted to write a conditional, and I haven't written that yet because I know there's this other case. So then I write the other case, and I say, okay, now what if foo is false? I want to make sure bar does not happen. And usually you don't have to do it quite in that, like you don't need to mock out bar and like have totally fake testing. You can have a little bit more sophistication than that, because maybe bar will raise an exception, and then you can test, you just make sure that no exception got raised. So the goal, like, it's very important to keep in mind that TDD is about testing the properties that you care about. And so you just need to have a very firm grasp on what the properties you care about are. Now, the other interesting thing about TDD is that as you're doing it, you will notice, oh, wow, I didn't think about that range of inputs. Oh, wow, I didn't think about what if this happens, what if that happens. I could write tests for all of those things. And you could, but TDD should not be informing whether you write those tests or not. TDD is the tool. What should be informing whether you write those tests or not is, do you care what happens when those conditions are true? Do you care what happens when somebody passes in some random thing that's like some type you weren't expecting? Probably not. Probably the only test you care about in that kind of a situation is just make sure that your top-level error handler like does the right thing and sends the error where it's supposed to, because you're going to have unhandled errors. You're going to have bugs. Don't try to do TDD in a way where it's like will prevent every possible bug from ever occurring. Make the behaviors that you know you care about work like you want them to work. And then once you've resolved to do that, then the question is just like, okay, well, what behaviors do you actually care about your system having when you're running it? Don't worry about stuff that is just out of spec, out of scope. And I know that's tough. Like, sometimes it requires some thinking to like figure out what exactly that is. And that's why I kind of oscillate in my own personal design process back and forth between like, okay, now I'm doing some sketching and now I'm going back to testing, is because sometimes when I'm looking at a piece of code, I'm like, there's like 50 lines I want to write here, and I kind of know what they all are, but I'm not totally sure. And if I just write them all out and don't actually run them, then I can look at them and say, okay, well, back this up. Why did I feel like I needed to write this? Why did I feel like I needed to write that? And then go and write the tests. And go backwards and go forwards again.
All right. That's a really helpful framework. All right, and now we are getting towards the end of this. Just a few more questions. This is kind of the big final finale question. Keeping in mind everything you've shared so far, please walk me through in detail a difficult problem you've solved recently.
So Mimic had this issue where we needed to figure out how to represent arbitrary failures that could occur in a cloud service. And the failures, because when you issue a request to do certain things, almost unlimited number of things can happen. Some of them are documented. There's quite a few that are documented in various failure modes that they can have. And some of them are undocumented and are surprises, even to the people operating things, and you have to keep careful track. So we started off with the first sort of pass at the solution was done in the closed mode. We had this goal. We were like, okay, we need to represent failures, so let's go. Let's look at all the different parts of an HTTP request, and we outlined absolutely every one of them, and we looked at response codes and headers and network flows, and we made a big JSON schema for all the different things there, and we started implementing it, and it was really gnarly and nasty to implement. And so we're just like slogging away at trying to figure out a way to maybe simplify it a little bit. And so that was the problem, was A, that we needed to build this thing, and the B was like really complicated. And so the way that we solved it was we took a step back from what we were actually trying to do, and we said, wait a second. Why are we trying to make it possible to represent every single one of these requests? Let's look at the social context around this project, because Mimic is supposed to be a repository of real behaviors that you can get back from cloud services. So if we do it this way, if we go to all this work and solve this really complicated technical problem, which is probably solvable, but is like a pretty significant modeling challenge, representing all of the dynamic things that can go wrong with a HTTP request in a static representation as a JSON data structure. What we want people to do is to send us the errors they see. We want to represent those errors in a repository. So if we allow them to program the service by just posting this big JSON blob to their endpoint, then when they have their tests, they'll just do that once. They'll construct the failure they saw, put it into their test suite, and go on their merry way. So instead, we'll implement something much, much simpler, which is just that we'll have operations like create server, list servers, delete server, and then reactions, which are just like special case, different signature for each one. Like create server has a particular signature, and list servers has a particular signature, and delete server has a particular signature. And they all take whatever objects they happen to need to take. We don't need to model anything generic about HTTP. Probably a lot of them will get HTTP requests, but then we'll take that, and we will, instead of representing everything generally, the thing that you post will just be like what request you have, what reaction you want, and then maybe a couple of parameters for the reaction. And then reactions will have to be contributed into the Mimic project itself. And the irony is, if you look at this like kind of an absolute quote-unquote technical merit scale, it's a terrible design. It doesn't let you represent anything flexible at HTTP. It makes you depend on newer versions of the software for everything you want to do, and like it's totally like brute force basically as a solution. But it met the requirements of the software a lot better. It means that we will be building value in this larger and larger repository of failure modes over time. It'll be much easier to document. We won't have to talk about like theoretical mechanisms behind HTTP. People won't have to discover their own stuff for their specific test suites. And so the way that we solved the problem ultimately was by we did both of the things that I talked about. So first we stepped back from the specific implementation and this huge suite of test cases that we knew we were going to need to write. And we said, well, what are the actual properties we want to verify about this system? And then one level up from that, we asked ourselves again, well, in addition to what are the properties we want from this system, what are the social constraints of this system? What are we actually trying to build in terms of the community around this project, and what are other people going to be doing to evolve this code in the future? And we radically simplified the whole thing, and I think that was a pretty good solution overall. So is that a good grand finale for you?
Yeah, pulls together all your threads and it's clear and illustrative. All right, second to last question. Are there any sites or projects you would like to plug, including any of your own stuff?
I would definitely like to plug Mimic, which I guess I already have. That's github.com/rackerlabs/mimic. I would like to plug Tubes, which is another thing I've been working on. github.com/twisted/tubes. And I could do a whole podcast interview just about the technology in there. There's some basic docs. It's for doing data flows with Twisted, if you're interested in Twisted. Twisted at twistedmatrix.com. Everybody should use it for everything. And there's one other project I discovered recently called Toga, and I can't remember the URL off the top of my head. It's a Python GUI library by Russell Keith McGee, I believe. I'm going to feel terrible if I messed up his name, but it's a kind of quick and dirty UI toolkit for dev tools, which still looks pretty good. Like, it looks better than tk-enter. Lets you use more native widgets, but it's still like super easy to use, cross-platform. And I want to plug that one because I feel like developers often, like those of us, I'm sure you're in the web development community. I am too. We're all server-side, back-end stuff. Sometimes our own like computing environments are a little bit static. Like, we don't feel like we have control over what's actually going on our own computers, even though we've got like this giant back-end thing that we have all this control over. So I like to encourage people to write their own like little command line tools and GUIs, because the GUI can also, if you're not too experienced with it, can feel a little bit alien. And so Toga is a good step in that direction. And I would like, and especially because if more people wrote GUIs and stuff, more people would be frustrated with the fact that setuptools makes it hard to like make a little GUI and like package it as an app or an exe. Like, the process for doing that is confusing, and there's not a lot of community. Like, it's not actually hard. It doesn't actually require a lot of work, but it does require a lot of understanding at this point. And if we could really smooth that ramp down for newbies, projects like Toga would help us like get more folks into the community. So you can, and although Toga doesn't have Twisted support yet, Twisted does have support for GUI event loops. So you can write your like back-end production quality web server and stick it into a little UI that you run on your desktop, no problem. So definitely check those out. Try to use them in combination. Mess around with them a little bit.
Very cool. All right, the last question. If you could give one piece of advice to yourself at age 15, what would it be?
Now that you know what variables are, you should probably check out classes. Yeah, I definitely would have. I mean, if we're sticking to programming advice, and not like just buy a ton of Apple at $15 a share. Yeah, I think I would probably focus on like learn about abstract programming concepts a little bit earlier, because I know everybody gets into programming for some of that immediate gratification, messing around with like a web page in JavaScript, making a little video game in Unity or whatever. Those sorts of things provide a little bit of initial appeal, but I waited way too long past that initial appeal to get into like algorithms and data structures and that sort of stuff.
All right. Well, thank you, Glyph. This has been fascinating.
Thank you. It's great to have an opportunity to rant and ruin a bunch of impressionable minds with my crazy ideas.
All right. Great. Signing off.